Example 12. Find the exact position and nature of the stationary points of this function. Y equals x subtract 2 multiplied by e to the power of negative x. Again, let's decode what's being said here. We want to find the exact position, so that means we're going to need x and y coordinates of the points, and we need to find the nature, so that means classify them. Is it a local maximum, a local minimum, or a stationary inflection point? And I just made that up right now. Stationary inflection point, SIP. Okay. First thing we need to do, just like we did before, find the derivative function. So dy dx. This is a product, so we need to use the product rule. So good job remembering what to do here. Let u equal x minus 2, so u dash is 1. Let v equal e to the power of negative x, so v dash is e to the power of negative x times the negative 1. That second part, remember, is the derivative of the exponent. Simplify that, negative e to the power of negative x. dy dx, u prime v plus u v prime. Simplify e to the power of negative x, subtract e to the power of negative x times x minus 2. We can factor out an e to the power of negative x. 1 subtract x minus 2. So 1 subtract x plus 2. 3 subtract x. Another way of writing this would be 3 subtract x over e to the power of x. So you can see that your algebra skills need to be right up to date in order to solve these questions. That's the derivative function. Now we need to draw a sign diagram of it. And in this case, I should call it dy dx, because that's the notation being used. So we need to think about what our critical values are for this derivative function. Is there anywhere on the function where it is undefined? And there is not. Even though there's a denominator here, e to the power of x is always a positive number. Okay, remember, any number to the power of x is going to always be a positive number. Even if x is negative, it just means that that number is a positive fraction. Therefore, there's nowhere where that's undefined. So no asymptotes. The zeros occur when the numerator equals 0, or the entire function equals 0 for that matter. But you can see the reason why. Okay, when we multiply both sides by e to the power of x, we get rid of this one down here, and we multiply this one up here, but that times 0 is still 0. So x is 3 is a 0. So sign diagram, our critical value is 3, because that's one of the 0. That is the 0. Try some numbers in here. If you don't know what that looks like, it's fine. Just try some numbers in here. Something smaller than 3. Okay, so f of, let's say 0. That's an easy number to work with. That's 3 over 1, which is 3. That's a positive number. So positive. Something bigger than 3, let's try 4. 3 subtract 4 over e to the power of 4. That's going to be negative 1 over e to the power of 4, which is a negative number. So negative here. Now remember, what does that mean for our original function? It means that f of x is increasing up until 3 and then decreasing after 3. Again, this means that we have a local maximum at this point. Okay, but we need to know the exact position of that point. We haven't done that yet. So we need to know what y value goes with that x value 3. So let's determine that. So f of 3, that's where it occurs, is from our original function 3 subtract 2 times e to the power of negative 3. So that's 1 multiplied by e to the power of negative 3, which is 1 over e cubed, meaning that the point is 3, 1 over e to the power of 3, and it is a local maximum.